Hi everyone, I am Jing and from China. Now I am working on ERT with Professor Alexandro Talentino and Professor Assistant Bruna in the University of Strategic Light from 17th October 2016 to 13 April 2017. I wish to acknowledge the support of the European Commission via the Maria Career Project. This PowerPoint is for the special season of the Geophysical for Urban Underground Space Development. I would like to thank Professor Liu Lanbo for offering this so precious opportunity to publish my work on the application of geophysical to engineering and environmental problems. It is particularly grateful to Professor Li Xiaozhao for supporting me to exchange my idea with Professor Alexandro Talentino, and appreciating Professor Talentino for helping me with this work. I will keep working in the field of development of refined geophysical application on surface structures and petrophysical parameters. And this is my title of my project, named Research on Relationship between Electrical Points. Is a background. And the figure one is a research zone, which is carried out in the Gansu province of China. The figure two is the aerial photo of the multi-scale fracture by drone. You can see there are a lot of kinds of the fracture in this research zone. Due to tectonical moment, fault fracture zone, injuries of the nuclear area, and the influence zone, these multiple sets of the cracks can make poor conductivity and low permeability coefficient of the development of the hard rock fracture seepage channel into different scales. It is likely to become potential groundwater migration channels. So, the field of the underground engineering is facing huge challenges. To more accurately grasp the characteristics of the permeability of the rock mass and fracture in different scales, analyzing phenomena of geological structure internal model, genetical mechanism and dynamics principle is particularly important. Fracture and poor medium migration rule can provide a scientific basis for underground engineering. The figure 3, 4, 5, you can see the fracture zone, damage zone, and the surrounding rock fracture. These fractures are exactly what we want to research. Different scales of the fracture have different meaning, and they are granted on the scales of the structure surface, which is generally divided into five grades. The first and second grades fracture can be referred to as fault zone, the main research to control effect to regional structure. Fault in the length and width of the difference is the microscopic guide water dominant factor. Third, fourth, fifth grade fracture. It can be collectively referred to as joint management, and it is relatively small in scale, with the main research on outcrop, palm surface, and probing fissure joint. The extension length and opening degree of the joints are the main factors affecting the local stability and the permeability of the rock mass. The fig 6 and 7, you can see the one, the second, the first, the second, third, fourth, and the fifth grand fracture through the draw and the photograph. So, most of my project you can see from the figure 8, the sketch of the nuclide transporting in the multiple scales of the size and the depths of the fracture. I want to figure out the relationship between the apparent resistivity and the multiple scales of the size and the depths of the rock fracture with ZRT. The first one is the size, the second one is the depths, and the third one is the how to reflect the effect of the plastic tube. Stands for higher resistivity or iron tube, low resistivity, and in the tank. the tank stands for the rocky resistance with the ERT. So this figure 8, you can see this is a nuclear with the times goes by and the nuclide transported in the part. Principle of the technical method. You can see from the figure 9, we use the four electrodes into the ground and to calculate the apparent resistivity is calculated from the electrode positions, current, and the potential by the equation. You can from the equation one, and the position of the current electrodes different, so you measure the difference k. You can calculate from the equation two. Equation three is a reflected image of the current electrode. And from this equation, you can to calculate the principle of the technical method. The measurement of the induced polarization IP is RES2 is mainly serial. RES2 with its 10-channel receiver allows simultaneous measurement of several potential response and thus makes the measurement faster. So this is a equipment we use to do our third part is methods, parameters, and equipment. 10 different equation of the sketch map. You can see from the different position of the electrodes in different kinds of the measure methods. But the 10 of the R can also be calculated into the same parameter. But I'm going to choose one is the first one, Werner Schoenberg. Equipment and instrument I use this you can see from the figure 14. The first is electrodes, and the second is a minimal couple electrodes, and the third is a tank, and the fourth is you can see this is RES2. That's what we call the ERT, and this all the equipment and the fourth part is the forward inversion and the experiment. This is the forward modeling. I just build it as the experimental test, like the tank, the same size and the same condition. This is the plastic, the PVC tube I placed into the tank in what you call hyposonicness flow rate. This is forward modeling. I use the Swedish high density software, REST 2D motivation and modeling and the rest 2D immersion to calculate the PVC cube. From the left is pure water, and the right of the side is a PVC tube. I placed in level. You can see it has a good effect. This is I use the advanced geoscience corporation Earth managed 2D high density software. I calculate it like the high and low resistive fracture tube. The tube is 2 centimeter in length of the side. High resistance is for air, and the low resistance is for water. You can see there's a good response, abnormal response of the forward model and exploration design of higher and low resistive tube. The area I used when Schoenberg. I just simulated as the fracture channel. The blue stands for the water channel, and the red one is stand for the air channel. You can see the abnormal response of the. This is stands for the crooked fracture. The blue one is also the higher resistive, the low resistive the fracture channel, and the red one is stands for the higher resistive the crooked fracture. That also has a good effect, but not very good. This one is a 3D immersion simulation. I used the Advanced Geoscience Corporation Earth Image 3D higher density software. The same size of the as a modeling, forward modeling. You can also see some of the good effect of this, but the abnormal response size is not the exactly like the modeling size. This is a abnormal response size map of the high and low resistive tube. The is stand for the fracture channel. And you can also see some of the good effecting and exploration desire on this figure 26. This is a abnormal response slice map of the high and low resistive fracture channel. So after all this, the forward modeling and evolution simulation, I carry out a lot of experimental tests. This is position of the PVC tube in the tank, and this is a flow rack. This is the position of the tube in the tank. You can exactly the same size, position, the electrodes, some of the parameter of the electrodes. This sixth photo stands for the experimental test procedure. The tank, the fracture model, and the purple electrodes and instruments, and the forward modeling and the immersion simulation. Finally, I come to into the get some of the results of the physical simulation test of the small scale fracture monitoring issue in the picture. I carried out a lot of the tests, but this one is typical. It has exactly what I want. The position of the low resistance channel in the figure is consistent with the position of the PVC pipe in the tank, and the effect size is good. You can see from the figure 13, 30. So let's move to the result. I come up to four, come up with four conclusions. The first you can see from the blue represents low resistivity and the red represents higher resistivity. There is a obvious low resistive channel in the middle of the tank. That's what we want. The second one is the position of the low independence channel is inconsistent with the position of the PVC tube in the tank. The third one, meanwhile, because of the boundary effect, length of the low independence channel is much longer than the real size of the PVC tube. So such as so many good ideas. I want to replace the pure water and mix it with a drier sand, such as. So I will do it in the future. I do some the field in the Gansu province. I through the air out group bare hole and tunnel 4 steps. I come to geological observation technology to find out. We also do a lot of the geological exploration and survey in the Gansu province to find out which is the site is good to detect. So finally, we come up with geophysical detection. One is a high density electrical process, that's ERT, and we place the two line parallel and vertical line layout of the core of multiply transistent surface wave. All of the two effects of this, the float core rock interface and the complete form. Most complete rock interface buried deep below the surface of the 20 meters, and some less a lot of the kinds of the multiply cracks, the fracture in the figure 31 and the figure 32. Um, I want to thank the Professor Alexandra Talentina again and Bruna. They do a lot of the help to me when I was in the University of Strathclyde. Also, I want to thank the Professor Li Xiaozhao and Professor Liu Lanbo that give me a lot of the chance to explain what I want to do and my good ideas to publish on this special season. So I will carry on my research deep and deeper in the future to do a lot of the sacrifice to the geophysical and um, the geophysical and detection. So Thank you for your attention. Cheers.